All right, guys, in today's video, I'm going to be working on this Pelican Big ED rechargeable flashlight. This is like a first responder type tool, and it's normal for these lights to be on if there's nothing installed. Typically, when you put the battery into the light and push it in here, these will flash rapidly until it charges, and then they'll turn green. And then if you put the battery in the back, it'll charge up there. But there's obviously something wrong with it. It won't charge. And what we're going to do is we're going to rebuild this very simple nickel cadmium chemistry type rechargeable battery. So let me show you how we would go about doing that. So this model used to have just 4 alkaline batteries, and then at some point they upgraded it to this. It's long discontinued. This number 3759 is the catalog number 3756301-004 for this particular 4.8 volt, 2.4 amp hour battery. You can see very clearly inside the black PVC shrink wrap, we've got 4 cells. They actually like they're size C rather than size sub C that you normally see. On the back, we see there's 2 contact points for charging, or excuse me, for either charging or just there because of the wiring in series. I can see 1 spot welded tab here. I don't see anything here. And then there's 2 foam cushions down on the bottom, and we can kind of see something down here as well. So what I'm going to do is we're going to go ahead and break off these spot welds so we can extract these cells. So this looks like it's going to be fairly weak, so we can side here. I'm just going to come in here and zoom in. I'm just using a small pry bar to get under this tab. And we got a couple of different tools here to help us out with problems like this. Got a pick as well. Just trying to get this guy up and off the metal. There he goes. So we can get this under like that. Hopefully you guys can see what I'm doing. It looks kind of blurry. I'm not sure why the camera doesn't want to focus on this. There, it looks a little better. All right. And we're just going to overcome these little spot welds by prying left and right on this tab. Now, if we end up not being able to salvage this and they end up breaking, that's okay. We can replace them. All right, so that one's off. So there shouldn't be anything holding it at the top. Let's test that theory. Yep, so the top piece looks like it's going to let go, or the top 2 cells rather. Come on. All right. Now the bottom, looks like it's just the same deal. So let's just get under the spot weld again. Break that. This is just glue. Same thing on here. Get under here and break that spot weld. All right. So we don't want to lose the orientation of these. We want to keep it like this. But what I do need to do is I need to get in here and see what specific kind of cell is used in here. So we're going to cut the PVC now. All right, so it looks like each cell is then spot welded together rather than it just being friction. I thought maybe it was just being held with friction and the PVC tape. All right, so now we know what we need. It is definitely a C cell. Just to get the rest of this PVC off of here. PVC shrink wrap. See if we can get some kind of information about this. Nickel cadmium, made in the EU, made in France specifically, 1.2 volts, 2300 milliamp hours. We can do a lot better than that nowadays. We will stick with nickel cadmium chemistry just so we don't confuse the charger. You know, some people might say go to nickel metal hydride, but I try to keep the same chemistry as whatever I find when I do something like this. All right, let's go get some cells, 4 cells. The only company that's going to make an actual size C rather than a sub C nowadays in this nickel cadmium chemistry is going to be Tenergy. So we're going to hop on, order 4 cells from Tenergy, and rebuild this. All right, what we've got here are 4 Tenergy nickel cadmium full size C cells, not sub C. It's like I think I mentioned in the previous clip. This particular battery pack, what was originally in there is a full-size C battery, right? And so that's typically going to work out to around 26 millimeters in diameter, and that's what we see with these replacements. And it's going to work out to around 50 in length of the body. And that's what we see with these replacements. When you measure these, make sure you do not connect negative and positive by accident. Just do it on the outer edge. All right, so now let's proceed to do this rebuild. It's pretty quick. First thing we're going to do is we're going to take the original connecting strips, and you got 2 options here. You can either replace them or reuse them. I have a pair of like jeweler's type pliers that are flat with no teeth that I use to smooth these kind of things out. And as long as they're not all torn, you can reuse them. If they are torn, you can cut a set of replacement strips. But only if they're torn or ripped or they've got some sort of corrosion going on. If not, I tend to reuse them. But we do need to get them flattened out. And then on this particular battery pack, besides these 2 that connected the 2 cells for each stick, we had this little guy in the back here. I don't know if there's a resistor or something in here, but we're going to reuse it as is. Same deal. We're going to flatten it out. And it looks fine. Okay. And then on the actual housing, right, we had this tab at the very top here. So what we're going to do is it folds around. We're just going to gently bend it down because we don't want this piece to break because this is part of the housing. And we're going to do the same thing. Flatten it out. Just like that. And we'll push this back up into position so that we can spot weld it to the top of the cell when we get to that point. All right. Now we just have to make sure that we left these in the right orientation, and I tried to do that. It's always going to be positive to negative. Always, 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 always. So you're just trying to determine, well, how was the arrangement in the original pack? And so I kept it the way we found it here. So this side had the negative facing there, had the positive on top. This side had the positive facing down, right? Then this positive goes there, and the negative faces up. And what we'll end up doing is spot welding this tab that we just straightened out onto this negative terminal there. All right, so let's just go ahead and get started. So we're going to need 1, 2, and 1, 2. And then to get these going, we're going to take the original tabs. You just need to have a spot welding machine. It doesn't matter what brand or type. This one is a CSI. And I've got it set for the thickness of this material with a 1.2 second delay. I like to do a couple in each corner. Just making sure that we got the right thickness. This particular machine, what I'm using is a setting of 3.0 and 1.2 seconds. Okay? And then we'll take the negative side and we'll do the same thing. Once we get one of these, it'll kind of hold itself. And we'll do this one over here. All right, and so this particular cell is rebuilt. So we got a stick for this now. Same thing over here now. Take our tab again. And then we'll do it on the positive. Trying to take in less slack this time so that it folds easier. Come on. Stay put. And then one more. Okay. We're done with that. And then we're just going to get it to fold evenly. All right, so now we just need to spot weld this little piece on the bottom, and then we can put it back inside. But before we do that, we're going to need to re-shrink wrap it to keep the sticks together. I'm going to do that with some PVC shrink wrap in black, just to match what we had here. And then this is going to be roughly, I think probably it'll end up being roughly 100 millimeters, just because we took 250s, right? Yep, that's roughly 100. So what we'll do is we'll cut a little bit of excess on this. We'll do it around, I don't know, maybe 120, 125. Let's see. So I'm just going to come out to 100. And then I'm just going to come out to 25 more, roughly. Doesn't have to be exact. We just want to get a little bit of overhang. The hard part is to get this on there, because it's going to always want to close itself. At least that's what I've always found. All right, there's one. We'll cut one for the other one, and then we'll bring over a hot air gun and we'll shrink it on. All right, I'm going to put the heat gun on here. I actually ended up cutting another 10 millimeters off of this, so I brought it back closer to 115 just to make sure we don't have too much overhang. So it goes pretty quick with the heat gun. What you want to have it do is just shrink down and hold the two cells together. Want to make sure they're roughly in the middle of what we cut. This one here Didn't come out the way I would want. We're going to end up with some excess on top here. All right, you don't want to get it too hot because all this is to keep the cells together in a stick. I'm going to go ahead and let that cool, and then we'll trim off the excess on the top, and we'll spot weld on this bottom piece next. All right, with that trimmed up, we're going to come up on top here. Again, remember, we're mirroring this side with this cell stick and this side with this cell stick. So now we're going to come up and we're going to do this piece. Right. So let's see. Looks like that should be fine. We'll use the same settings that we used for the individual cell strips. It's like you need like a little holder or something, really. Okay. Now we can take this guy and work him back into the plastic piece. Making sure that the one on top stays on top. All right. And now, this will be the hard one just because of the shape of our spot welding prongs. Let's see if we can get this to fit in here. I might have to take our insulator off here just to get it narrow enough. What I'm doing now is I'm just trying to get it to bend and make contact with the cell. This one. See if we can get this one right on this outer edge. Okay. All right, so now if we turn off the spot welder, because we are done with that, and plug this charger back in, we should have it charged now. So it's not complaining. So now I'm going to put it in the light. All right, guys, I had to stop this for a second because I realized when this is in the charger, this is supposed to blink. And what I noticed was this little negative prong in the back that the charger wants to see when it's installed in the light. I think we accidentally flattened it when we were doing this job, because now that I've bent that back, course, now it's fully charged because it's brand new cells. But this is supposed to flash red when it's charging, and then it goes to green when it's done. If it's solid red, nothing's happening, right? So I think if we run this down a little bit and then we put it back on the charger, I can show you the flashing red behavior that you're supposed to see before it turns to green. All right, guys, I'm going to insert this clip right here for a different problem I ran into. So after fixing these two tabs being bent, we got through the rest of the video, the problem I was noticing was that the flashlight would shut itself off after 5 minutes. It was just like you'd hit the power switch. And for a second, I thought it was a dead or defective cell, but it turned out to be this little guy, this little thermal protection device that we reused. And so if we take a multimeter and we measure the resistance on this guy, this should be fractions, a fraction of less than 1 ohm. And what we see when we measure this guy, if I can get the probe to stay on the tab, we're getting upwards of 14 or so ohms. That's a problem because in normal operation of the flashlight, 14 ohms with the kind of current we're talking about with these new upgraded cells is going to create enough heat to trigger this thing. This particular one is a VA model thermal protection switch from Peppy, Portage Electronics products, and it's set to trigger at 70 degrees Celsius. So when it gets up to 70 degrees Celsius, it's going to switch off. Because it's obviously already damaged, it's probably not even getting up to that trigger point before it activates. But that's where the switch that was shutting off the flashlight was. So I got a replacement one, same model and same trigger point on the temperature. These codes in the front just have to do with where it was manufactured and the week of the year that it was manufactured and the year. This particular one here, the code tells us that it was made in 2009, and then this one here is made in 2025. So if we take the resistance measurement on this new one, put our probes back on here, what we see is what we expect here, right? Just a fractional amount, just around a half a ohm. So that's what we should see. So we're going to spot weld one of these in place of the one I took off of here, and we should be good to go. Now this is hard to get because these parts are normally only sold to companies that are building battery packs. It's hard to get them as an individual. I was able to get some samples from a local distributor. What's more commonly found is a bulkier design like this Seke ST22. This is also triggered at 70 degrees. It's just a bulkier design. To use in this application we've got here, we would need to cut these leads back and solder a couple of nickel tabs so that we could spot weld it in place. And then you could use something like this for the same purpose. I'll put some links in the description for similar models like this. There's a couple of different models like this. Now, Seke makes an ST30 that is very much closer into size to this Peppy one. As you can see, the thickness is the problem. But that also was hard to do. I couldn't even get samples of that. But these ST22s are more readily available. But if we show the resistance measurement on this guy, now similarly, we'll get a fraction of an ohm. In this case, it's going to hover around 0.3, 0.4. Looks like it's going to be happy at 0.3. So all of these types of protection devices should read well under 1 ohm. If they read over, like this one, they're defective. So we lost some time farting around with this because it turned out to be defective. All right, with that battery run down a bit, now you can see the flashing red is what you're supposed to see on this. And then when it charges back up, it'll turn solid green. So I'm going to let it sit, recharge back up to solid green, and then we'll take some voltage measurements on the pack. All right, and so now it's charged with the 2 greens instead of the flashing reds. And push this button and take this guy out. And let's see what the full charge of our rebuilt pack ends up being. Get this over here where you guys can see it. Negative and positive. 5.45 volts, 5.44 volts. And that's great because each one of these C cells is around 1.2 volts each, right? So 1, 2, 3, 4, 2, 4, 6, 8, so 4.8. Anything over 5 is great. So successful rebuild of a battery pack for a Pelican Big ED rechargeable first responder flashlight. I hope this helps you out on how you might rebuild one of these discontinued battery packs. If you got questions or comments, go ahead and leave them below and I'll try to help. If you found this useful to keeping your old light going again, I'd appreciate you paying it forward by hitting that like button. And as always, thanks for watching.